How many of you are attending? Okay, I expect everyone to show up over there, so one will be taking attendance. Just kidding. So if you haven't signed up, please do show up. It's a holiday party, it's a networking event. So it's community driven. We are doing this in coordination with several meetup groups. So it's not just the big data. So you have MySQL, PHP, Couchbase, you name it, we have it out there. So it's a good way to meet the community folks out there. We also have several companies coming down. If you want to talk to us what different companies are doing with the kind of technologies they're using, kind of tools they're using, you should please attend, network and talk to them. Other than that, tonight we have Jack. He's going to be presenting, and I'm going to let Jack do the talking. So without further ado, Jack.
Thank you, Subhash, and thank you for our host. Really appreciate the space and Subhash setting this up. Subhash mentioned I'm Jack Dudenkoff. I'm currently started a startup because everybody has to do a startup now and then. And basically, the company is big data infrastructure, big data infra. Feel free to ping me if you're looking for help on any kind of stuff that we're going to talk about. Basically, the whole data pipeline and big data infrastructure supporting analytics. I'll give a little bit of background on myself going through the slides, so I won't go through a whole lot of stuff. But basically, the slides are going to be extremely dense, full of information, because I wanted to give you, and I'll post this up on SlideShare, but I wanted to give you the slide deck so that you can kind of look at it later on and kind of get a little bit more information rather than just me hitting a bunch of bullet items and then you leave here, anything to take with you. I titled this No ETL, and I completely lied to you. There's no such thing as a no ETL if you've ever dealt with anything to do with data. But it's all the rage. Just kind of like NoSQL was all the rage for a while until people realized that they actually needed SQL on top of things, even like Cassandra and HBase and key value stores. Frankly, I think it should be called no-rel rather than NoSQL. That's just me. Be happy to talk about that. But no ETL, I think there's a little bit to truth to that, and I think it's really about the extract versus the transformations and reshaping the data into some kind of structured data and then some loading, but we'll get into all that. So in some regards, I do agree with the no ETL from the traditional kind of extract model, which we'll talk about. But mostly what I want to talk about, because everybody has some new flavor of everything from ETL to ELT to no ETL to Lambda, and I've been kind of prescribing this new thing that I talked about at the Boston Developer, or the Big Data Developer Conference in Boston. Are there any Vertica people here that familiar with Vertica? MPP, Polymer Store? Okay, fair enough. Then everybody else is going to be bored. No, I won't go over a whole lot of things there, but so some of this comes from that talk that I did there. But really what I want to talk about is parallelism through the entire data ingestion pipeline, which we'll talk about. So from streaming to doing your transformations, reshaping the data, and then loading your data, whatever your eventual target store is, whether it's HDFS or if it's a relational database model or something in Vertica. So, substitute whatever you like, Redshift, what you guys are using. Okay. Is everybody else just writing into HDFS and Hadoop or something? Sorry. Apparently it works now. Just so I can get a sense for everybody else, Spark. People in the audience that are using Spark. I know you're having problems. Spark, yeah. More in development or in production? A little bit of both? Yeah? Okay, cool. Okay, so that's good. How about Kafka? Anybody using Kafka? Okay, cool. Or evaluating Kafka or using Flume or Scribe? Sorry if you are. Maybe something. Okay. Okay, so let's go ahead and jump in a little bit here. So, like I said, just fair warn, I violated all the best practices in PowerPoint. So to do like 3 bullet items. I worked at Microsoft for 15 years and I did a lot of talks. So I've been trained not to do everything that I just did here. But I haven't worked at Microsoft for a while, so I'm going to do whatever I want. So there's going to be a lot of information, it's pretty packed. So I'll stick around and be happy to talk to everybody about it later on if you want to keep drilling down. So I'll probably just take questions at the end, if you can, because there's a lot of material here to cover. So try to remember what you wanted to ask me. agenda, give you a little background. Some I've already given you, some on myself, some on kind of how I came to evolve my thinking around data pipelines and how I got there, including Lambda influences and stuff, which we'll talk about. Then I'm going to give an overview of PSTL, so think streaming, transformations, and then loading, but all in parallel. So parallel streaming, transformations, loader, think Kafka, Spark, and then whatever your target store is, whether it's Vertica or something else. I'm a pretty big Vertica fan, so happy to talk to you about that, versus like say Redshift or something. And then I'm going to talk about the parallels in Kafka Spark. I already kind of gave this away. And then I'm going to drill down on actually some of the details. I wanted to really give kind of prescriptive guidance around the whole data pipeline, the big data infrastructure, rather than just kind of waving a bunch of hands and saying there's streaming, et cetera, and such. So I'll literally walk through every bit of functionality that we implemented in my prior capacity, where I was VP of Big Data at Vertica. And then some Vertica performance numbers that are pretty impressive using this architecture, so we'll talk about that. So starting with the background, kind of my background, kind of how we ended up here. I've been doing this for about 29 years, so I'm old, is what I'm saying, really. But what I've seen, starting with right out of college, started with the 4GL, relational database management system, so clearly I have a bias around relational data, but it kind of colored my thinking pretty early on. So I was MIS director of several startup companies back in the day, so I've been a startup thing for a while. Then I was a self-employed consultant, where we did things like intercepting all the database calls in this 4th generation language to retrieve data from btrieve, and then honestly this seems kind of crazy, but what we did was we used this 4GL language to actually write data into DB2, so that you could actually write code really fast in 4GL, but store your data on the big iron. So I've been kind of in the database realm for quite a while, all the way back to the Box Pro Sybase before it was Microsoft and SQL Server, etc. And then just general design patterns have always kind of fascinated me as well, which we'll talk about a bit more. I was a lot of things at Microsoft. I was there for like 15 years, where I invented this system called Shuttle. It's think about an ETL system that you don't have to write code for, but it's completely extensible. All of MSN.com data, including Bing Mobile, I think is using it now. So all kinds of data flowing through that system. I think it's actually one of the longest lived products next to Windows and Office product actually. So it's been around quite a while. But this started my thinking around distributed processing, in particular in a traditional ETL pipeline, and the power of scaling. We built it off the back of Microsoft MSMQ, kind of like RabbitMQ if you've used that. Kafka I think is a much better queue model, if you will. Anyway, some of the people that influenced me there is, back in the days of star schemas, Ralph Kimball, etc. And particularly this person, Steve Butler, who was an architect there, kind of influenced my decisions in architecture. Then I was at Twitter for a while, kind of pre-IPO, through the IPO, and post-IPO, where I was manager of the analytics data warehouse team. Basically think of, is this getting louder, or is it just me when I hold it closer? Or is it too loud when I, yes? No? Okay, not too good, okay. Because I can just forget. In the early days, I was in the core storage team, Hadoop, HBase, Cassandra, and then Blob Store, which is our binary large object store for images and photos. But mostly what I was really involved in was Vertica, which is an MPP columnar store, scales like nobody's business, where we were moving a lot of stuff out of Hadoop, and instead of running pig jobs. Pig was pretty big because a lot of committers weren't on our team. But basically all the data in and out of Vertica from Hadoop and HBase, etc., was kind of my team's responsibility. And then kind of coloring my thinking were the Professor Stonebreaker and such kind of colored my thinking at that time. Moved from Silicon Valley down here a little bit ago, a year and a half, 2 years ago or so, where I was Playtika's VP of Big Data, which I'm going to give kind of a canonical example here pretty soon. People that influenced me through this process were Jay Krebs. Did anybody here see Jay Krebs when he was here recently? Yeah, from Confluent. Love that guy. Mostly because when you build things, it needs to be operationally robust if you have to support it. That's one thing if you don't. And kind of the founder of Kafka. And then Mike Lambros, Spark SQL, love Spark SQL. We'll talk about it some more. And then Chris Bowden was one of our architects on our team. Basically, he's just a dev demigod, and he wrote some of this stuff. And you'll see some of these perf numbers, which are pretty impressive. Okay, so basically, I was on a quest for many years to build a unified data pipeline with parallelism throughout. From the streaming of data, through the transformations, reshaping of the data, from semi-structured to structured data, into relational data and all points in between. So I've been thinking about this for a while, doing a lot of research, with a lot of companies, a lot of experience, and what you're going to see is kind of the fruits of that labor, and you can borrow some, all, or I can help you build some or all of it as well. But the main thing was, it had to have the attributes of operational robustness, because it has to have high availability. For example, when I was at Twitter, even though I was a manager, I was on call 2 out of every 4 weeks. And that's a pretty big task to be on call supporting all the analytics team. And so, you want to build things that don't wake you up during the night and keep you up at night, which you did an okay job of, sort of. So you want strong durability guarantees, item potence. Clearly you want to be able to rerun jobs. You want to have things be operationally robust, and you want a rich development environment as well, which we'll talk about. One of the reasons why I like Spark. But of course, it has to be performant at every layer and every tier throughout your data pipeline. That's pretty key. So we'll talk about that. So I stole this from Wikipedia. Clearly. This is the traditional ETL, as we all sort of know and loved at the time it was created. I think some of the things that are kind of interesting about the ETL, in particular, that have changed slightly, are the extract. Back in the day, you had big corporations, you had data in different departments, and basically you were extracting, pulling data. Right? I think that's what's slightly different from a, say, Kafka model, where you'd like a central repository, a central sort of queue, if you will, where you can then pull from, kind of sort of a data hub. So I think that the traditional ETL kind of lives on, but maybe not so much about the extract as much as people pushing data to this kind of centralized location, which has other benefits we'll talk about. But fundamentally, the idea of, say, a no ETL or lack of ETL, I've never been in a company where you didn't have to do something with the data. It turns out, right? You want to reshape it. You need to have it be relational. You need to turn an epic into a date timestamp. You need to take something semi-structured and make it palatable and consumable by your analysts, by your data science team. So you're going to transform your data. That's a constant in all of these models, whether it's Lambda, whether it's ETL, whether it's no ETL. The extract could be different. There's a bunch of ways to handle that. But the transformations are going to always be there. And then frankly, I think the loading, unless you're not going to use the data, even if you're going to put it in some kind of key value store and you're going to do schema on read, by having data lakes, etc., you're going to have to put it somewhere, as it turns out. And you're going to need to manage that data. The thing that I find kind of interesting about this off of Wikipedia is that they say ETL supports massive parallel processing, MPP for large data volumes. I know what that means, and I'll talk about what that means. I'm not sure what they meant back in the day. All the ETL systems that I ever built were pretty monolithic, they weren't distributed. There was no massive parallel processing from when it was originally created. Maybe if you're running out of Hadoop and you're moving, transforms and functions, in a map-reduced world near the data in a distributed model, okay, I could kind of buy that, right? So ETL has served us pretty well for quite a while, all these years. And then along came ELT, which was, another flavor of ETL. However, you're mostly trying to take the data in more of a semi-structured format, usually putting it into a data lake, which is all popular now. And then doing your transforms once it's been loaded. And a lot of people did that. They would like load it in the SQL Server in the early days, and they do the transforms of business logic in SQL until we did Microsoft, shockingly. And then, we would do some transforms and such on the data. But basically, you're trying to get the data in there as much as you, as early as you can, and push your transformation, your processing to the back end. Granted, data lakes weren't all the rage back then, and semi-structured data and how do you consume it, like with Hive and such, didn't exist that much. But I think that the thing that I kind of like about this, that I kind of bolded here, is that it does require sufficient processing within the data processing engine to carry out the transforms. So one thing that's common, whether it's pulling it from MySQL or some other structure where you probably store, where you're not going to have to do that many transforms to the data, is that consistent in ETL and no ETL and ELT is you're going to have to do transforms and loading. So that makes sense. I mean, clearly it makes too much sense. And then along came Lambda architecture. So I was at Twitter at the time. Nathan kind of came. So our basically our data pipeline at Twitter was scribe logs. All the data went directly into Hadoop, and it was a lot of data. And then from there, ran pig jobs, etc., to consume the data from a consumption and analytics perspective. But we wanted to get more and more real time, even with the volume of data. So we built things like Storm. Have you guys heard of Storm before? Yeah. Okay. Cool. Storm was great for what it was great for and what it was built for. Happy to talk a lot about it, especially in comparison to like Spark streaming. So this top layer, the speed real-time processing, Storm was built originally for getting as close to the data as possible and getting analytics, sort of sub-second response times in the consumption of the data. But it was also considered like how, in fact, here, let me just jump ahead. Yeah. So, as I mentioned, Jay Krebs. So a lot of people started adopting Lambda, and there's a lot of benefits to it, mind you. You're going to Hadoop, you're trying to get streaming data, but the idea that you're trying to reconcile the two with two different, paths, like reconciling in the streaming model with data that's coming through a batch system. Is it just me, or does that feel weird, right? I don't know how to do that well. So I was having the same kind of questions, and thus I came up with a little different model, which you'll see. But this is from Jay. It's very verbose. Like I said, I just left it here so that you can read it later. But it's good information, and I'll save you the time for repping the internet to find these kinds of things. Here you go. But basically, it says the same thing. Why can't the stream processing system just be improved to handle the full pipeline instead of trying to merge it with the batch processing? Yeah, I like that idea. In fact, I liked it so much I kind of baked it into my architecture. So he's questioning Lambda architecture. So this is a slide. You'll see some slides that are kind of old that I did another talk. I won't spend a lot of time on them, but it does give some good context. So someone in the audience here as well worked at Playtika. It's a social online gaming company. It had several games like World Series of Poker, Slotomania, a bunch of other games. The thing that I wanted to show you is this was the original architecture when I came to the company. Very traditional ETL, right? You see up on the right-hand side, the things that I want to call out are some of the challenges that I know that we all have with processing data. So notice that, some company, some game X, some source of data, right? And it could be within the same company, yeah? So you have users and sessions for game X, call it World Series of Poker or something, in the case of Playtika, right? And you have another game, so, but notice the subtleties here that I have called out. The user ID is an integer in two of these games. Now, it's not the same integer because these companies were formed independently and they have their own data warehouse, right? So you have disparate data and multiple sources of truth, which is back to the whole ETL model of I have data all over the place and now I need to make it consumable. It's not, it's a typical problem. And then notice and by the way, those ints, they're not shared or reconciled for the users, right? When they create a user in their own system, they assign, auto increment or something, however they do it, snowflake, something, to assign the ints. And then the session IDs, this is even more fun. And by the way, this is how it was, where we were. The session IDs, one was a UUID that was 36 characters. So basically it was a GUID with dashes in it. And the other company had a UUID with no dashes in it. At least it was globally unique, right? And then the other one, session ID was a varchar 255. I don't know how you get more unique than a GUID or a UUID, but apparently you just slap a MAC address and a few other things on the end, and you're guaranteed that thing is unique. But that's what one of the game studios did. I removed the name to not embarrass people. But in any event, the whole point is that at some point, if you want global data warehouse or some kind of reporting and reconciliation, you have to have some commonality, right? You have to bring this data together, and so therefore you're going to have some mapping, some transforms or something. That's kind of the net result is what I'm talking about here. So the game applications, they would send data to us. We had the global data warehouse. They would send it in JSON format. The good news was it was a unified schema because all these other, they had other different data formats in their own data warehouse. So you have to have some kind of commonality, some kind of common schema. So here we are defining schema so that we can do mapping and transformations. You can't get away from it. We happened to go through a REST API. We used Flume, so it was just this big blob of JSON data, and unfortunately it was every single event, in one big blob, which was fun to kind of parse. And by fun, I mean, not at all fun, at all, ever, separate the data, which we'll talk about. Anyway, so I went into Flume, and then it's very typical, we had a Java ETL application, we'd read these, build some mappings. Sometimes it would actually pull our global data warehouse of source of truth with Vertica. Great MPP column restore, did I mention that? I like it. But, this is going to be the global source of truth for all the reconciled data. So sometimes you had mappings in here, domain tables and such, so the ETL would load those and do the mappings, right? So typical mapping, typical job. And then, so we're basically taking a bunch of single sources of truth and trying to come up with a global source of truth, so that the common data warehouse. But the thing to kind of note here is that thing right there is your biggest bottleneck, that ETL job application, and it's not going to scale at all. I mean, it's going to scale vertically, but not horizontally at all. So that was a big problem when we were having more and more problems. You think you have GC problems. And then notice here, the whole point of doing all of this is so somebody can consume the data, right? There's ingest and there's storage. But the whole point is somebody needs to consume this data in a palatable way. So the only analytics that you could really do off of this model, which might, it's self-evident obviously, and I gave you a hint, this structured relational data in this RDBMS, is only the analyst can actually use Vertica data warehouse. You're like, well, so what? That's okay. It is okay, but there's a lot of things that are missing this whole pipeline that's completely opaque. Like this data here, the semi-structured JSON, why can't you look at that data and why shouldn't it be available to analysts? Why can't you use that to verify whether you have bugs in your ETL to compare the data when it gets into here? So you'll see kind of that processing, and then frankly, kind of a separation of concerns as well for ingestion and consumption, because this becomes the single place where everything ends up. Which is sort of good and sort of bad. Does that all make sense? Sort of? Yeah? Okay. Too slow, too fast? Good? Yeah? Okay, cool. The people that are going it's too slow, you're going to love the next few slides because they're going to be super dense. So I kind of already walked through those. 1, 2, 3, obviously 4, and you can do the analytics. Okay, so that's a general overview. Now I'm going to give you an overview of the parallelized streaming transformation loader, as I like to call it, Pistol. Okay, so I'm going to start with the same thing that we had before, and then where we ended up with the architecture. Okay, so there's all your sources of truth. We already talked about that. You're going to need to do something with that. I mean, clearly they have to send you data. Clearly your API, because you have legacy now, your API is JSON. You can never change that, but we want that. So what we were doing was we had a REST endpoint, load balanced, REST endpoint where everybody sent JSON. You could have local Kafka clusters near the game servers, as a for instance, and then read off of those, or mirror those to your own where you're going to do your data processing. That's one option. Another option is you actually keep your REST endpoint, and then those write to Kafka. So either way, you can have game servers write to Kafka, your REST API can write to Kafka, and by the way, your REST API can take that JSON and write it to Kafka in Agro format. If you want some nice Agro binary serializable, blah 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 kind of format, but your API still stays JSON with your producers. Just something to think about. So one thing that this gave us was this kind of real-time messaging. And as most people that know me, I think real-time is kind of a misnomer. I mean, come on, there's nothing real-time. By the time the data shows up there, it's not real-time anymore, right? If you're going to consume it, it doesn't become real-time. Okay, as real-time as you can possibly get it by putting dashboards, but if you're going to do something with data and transform it, come on, it's going to be like semi-real-time. But still, the good news is, by having it onto Kafka here, instead of these opaque like Flume files and such, is that we can do stuff in real time here, like dashboards, fraud detection, a bunch of things in real time. Actually use the data, so it's not opaque as it's coming in anymore, even though it's JSON. In fact, we can expose this and make this available to all the game studios sending their data, and then we tell them they've been sending us crap that's going into the data warehouse. And they're like, no, we didn't send you that. It's perfect in my data warehouse. And I'm like, but no, you sent us this wrong data. You can make this available for them to look at their data and see what they've sent you. So real value making the data available as soon as possible for people and for your sanity, right? To see like maybe there's a bug in the ETL. Maybe you sent us crap. I can prove it's crap. Is it okay if I curse? Say the C word. Crap. So what I particularly like, now this is just the overview, and, we're going to drill down these details, so you'll see it again. Only it'll be even more dense slide. It'll be awesome. So reading real-time or near real-time messages from Kafka, we would write them, or we would process them in parallel with Spark. Spark has a pretty nice, by pretty nice I mean I really love it, ability to consume messages off of Kafka in parallel reading, parallel processing, into RDDs, which we'll talk about. So don't worry, RDDs, think of them as like just a table distributed in memory across a bunch of nodes. It's great that way. It's one way to think about it. But the beauty of this is that like this scales quite a bit. Notice that we have a cluster here. We can scale this out. Cluster here for the processing and transformation of the data, processing in parallel by reading the messages off of Kafka. Scale this out as opposed to just this ETL system, the Java app, right? Seen some benefits there as well. And then, because of the benefit and some stuff that I'll show you, there's the ability to read in parallel, read into RDDs in the Spark cluster, as well as, which I'm going to show you, and it's really cool. I'm just going to tell you right now. To write in parallel from RDD partitions directly into Vertica, directly to the node where the data is going to land, so you don't have shuffling involved, which I'll show you, and the performer is going to blow your mind. Okay, so what do we talk about? We have parallelized reading, streaming data, transformations in parallel because they're going into partitioned RDDs where we can do transforms against the data in memory in this cluster to scale. And then we're going to be able to read and load from the data warehouse in parallel. Now you see where I come up with PSTL. Okay, so what's the benefit now? Is that we can do analytics. I mean, if all of this wasn't enough, the whole point we're doing this is so that people can consume it, right? So they can make business decisions, and they can do machine learning in the number two, and then they can build models and use that for real time, marketing, etc. They can do fraud. You can do fraud detection. You can do faster analytics out of your relational MPP store over here rather than having to run MapReduce jobs and waiting for 3 days like we did at Twitter. And then it's like the old, COBOL punch card days. It runs for 3 days and you get a reducer that's hung up and you have to kill the job and I'm sorry you have to resubmit it. Like that's no fun. When you can get really good, like, less than 10-second response times from the relational model over here, and combined across all these as well as the power. So now we're getting analytics of semi-structured data, more structured data, non-relational data in the Hadoop cluster, and relational data. That's powerful. So now we're actually getting some real value in real analytics. Okay, so it's all about parallelism, right? Clearly about Kafka, Spark. But what does that mean? So for everybody here that's familiar with Kafka, you'd be like, yeah, whatever, I get it. There are producers, they write to the Kafka cluster, the broker, then there are consumers. But the thing you need to think about, especially when it comes to like Spark, is what does that mean and how do you define the topics and how do you define the partitions? And think about that. So this is literally just a slide that I stole, right? But the thing to think about, and then we can talk about at great length, is what are the topics? It's just a set of if you think of it in terms of, say, your target store or a bunch of tables in whatever Redshift, Vertica, or something like that, you can almost even say, like, well, let's have a topic per table. It's just some logical grouping of semantically related data. And it's completely up to you, the level of granularity that you want to have for the topic. And frankly, it's kind of really whoever's sending you the data is going to help define some of that. Because like I said at Playtika, they're going to send you a blob of everything in one big topic. Or maybe you could read it off Kafka, split it up, and put it back onto Kafka, right? Under different topics. Rate model, something to think about, just saying. So basically, you're just parsing data and then throwing it back on Kafka in more of a normalized or more of a structured format. That's a great idea. But anyway, these partitions. So as you partition the data, like think of partition per node in the Kafka cluster, it's basically just appending these messages, in our case JSON or Avro messages, onto the end of the partitions. And you can read just as I can read immutable sequence of messages, blah blah blah, right? And they're not specifically time, but they're time ordered. Whatever showed up here is just going to be appended from oldest to new messages. So then when you consume them, you're just going to consume them that way. But don't think in terms of, this message is at this time and this one's at this time. Because in partition 1 and partition 2, number 8, message on 2 and 8 could be completely different times. Okay, so just keep that in mind. Because as you're consuming the data, that becomes more interesting. Or if you have to reprocess the data, that becomes something you really have to manage, right? Okay, so Spark RDB, it's kind of funny because when I first came here, Subash to set this up and we went to the first Spark meetup. And the first question was, does anybody know what a Spark RDD is? And there are like 100 different answers. But this is it. It's an immutable partition collection of elements, objects, whatever, rows. It's getting a lot more formalized these days. But the whole point is that that's your level of parallelism. The number of partitions that you have in your RDD is when you do processing on that data, that's your parallelism. The beauty of it is we don't have to do things like multi-threaded applications anymore. We don't have to think about, like what we think about are writing functions that are operating on the data that we're going to operate on near the data instead of moving the data. That's the key in big data. Don't move the data. Move the process into the data. It makes sense, it's very clear, but let's look at that. By the way, I couldn't find a simple diagram in my head. Like, what is that? Like, where does the RDD live? Like, is it on node 1 always, and then node 2? Is it round robin? Like I couldn't, I'm a visual person. I had to actually create the slide, so feel free to crib it, take it, fine. I couldn't find it. So, the way I visualize this, an RDD, goes across all nodes in the cluster, or does it? So, let's say we had RDD 1, could have partition 1 that lives on node 1, partition 2 lives on node 2, partition 3 can live on node n. It's not node 3, but to be clear, it's somewhere in the cluster, right? Typically, if you think about, you want 2 to 4 partitions for each CPU in your cluster. Okay? So in this case, we had 32 CPUs per node in our cluster. So natural partitioning for us, for ingestion, bringing the data, and then doing transfers on the data, was like 64 partitions per node. Now think about that though, okay? So it's data spread across your Hadoop cluster, right? And if it's broken up by slices, think of them as rows if you want, or objects, however you want to like to think about it. If you slice it up, like in this case, up to 256 different slices of data, when you're doing transforms or reshaping that data and doing execution in 256 operations in parallel across multiple nodes in your cluster, that's really powerful, especially when it's in memory. And that's kind of why it's kind of taken over the whole map reduce world of like typical map, write to disk, read, write, back up, shuffle, sort, right? So imagine like, this gives you like kind of the nirvana of like distributed in memory kind of processing. But this is kind of the way I visualize it. And I just put this up here because don't forget partition 1 could be somewhere else and the ordering is completely different. So, you guys aren't here necessarily for all the Vertica, so I'm not going to spend a lot of time on this. But you should think about this. So how many people in here have a data warehouse? Even if you consider Hadoop your data warehouse, that's cool. I mean, that is a data warehouse, right? It's usually folder storage, yeah? Okay. Like Redshift or any other kind of relational store? Okay, cool. So I put this up there because people often think about, I'm consuming the data in a relational data model, or I have to process the data in some method, Java code, and I have to ingest the data somehow through REST endpoint or whatever. You need to think about the entire data pipeline. It's critical because your consumption of the data and whether or not it conflicts with the ingestion of the data, competing for resources, or the ingestion of the data and how it's going to impact how you shape it and reformat the data is critical. So when you're building your data pipeline, you have to think about it from the moment data is coming into your system or you're extracting the data, the old ETL model, the old extract model, and the time that you're processing it, and the time that you write it and reshape it, from a performance semantics and from like restartability and high availability, etc. So what this is just, I'm going to briefly go over this because there's not a lot of Vertica people here, but here's a typical table definition. The thing that's kind of interesting about this is that what they typically do is they'll hash, think of, you always want to have something that uniquely identifies a row, right? Typical database, 101, right? And you want to even distribution your data across all your nodes in your Vertica data warehouse. So typically if you're hashing on something that is unique, you'll get a good even distribution of data, right? Fair enough. But as it comes in, like in this case, you have to hash the order ID. So it comes into an initiator node, and which is like, say, node 1, okay? And it says, I'm going to hash this. Where do you belong? Well, I hash it, and you're going to go to node 2. And then I hash this, and you're going to go to node 3, node 4. I mean, correct me if I'm wrong, but if you guys are in the MapReduce world, does this sort of look like a shuffle to you? It's a lot of data movement, right? Like I send it to one node, and now I got to send it somewhere else, and I got to pre-allocate memory across the entire database. That seemed crazy to me. And at Twitter, at the scale that we were dealing with, and it's probably one of the world's biggest data warehouses in Vertica, now I think Facebook is. Zing is a pretty huge cluster as well, hundreds and hundreds of nodes. This, if you're thinking in terms of where's your bottleneck in performance, that's a pretty good indicator of where your bottleneck's going to be is in the shuffle, right? Same thing with Spark. Avoiding shuffling, same thing, MapReduce, reduce world, shuffling costs you. And then you start to get away from that parallel processing as well, right? Okay, so we know the Vertica hashes on these columns to know which node it goes to, and then it has partitioning as well. It's just partitioned, like your kind of date-parted stuff that you guys do in Hive if you do it on Hive and Hadoop, right? The same kind of thing. You just separate the data on disk into files. Okay, you guys ready for some real dense slides now? So, no surprise, I have an Apache Kafka cluster. I have topics, and in our case, we had applications, World Series of Poker, etc. Right? So we had an app ID to uniquely identify if we wanted to run World Series of Poker, and at the same time or independently, or give them more resources than other apps that we're running. So that's another thing you can do to kind of separate your data. You have a Spark cluster, right? I mean, this is your Hadoop repurposed now for Spark processing usually, right? And I'm sorry for all of you, like we did at Twitter, your data nodes or super cheap commodity, like no memory, not very good disk, and now you're in Spark and now you regret it. If you're getting data nodes, put a bunch of memory on it, just saying. You're going to want to do more memory. And then Vertica, separate cluster. Whole point here is you can scale this out at the top by adding more nodes to Kafka, right? You can change your retention policy, how long you want to keep the data on Kafka, and reread it, reprocess it. Same thing here. And on this side where you're going to consume it, and you have a separation of concerns now, right? You have a separation of ingestion of data concern, and how you can separate that from not impacting the Vertica cluster while all your analysts or Redshift or whatever you're using. So that as they're consuming the data, you don't have to manage the whole. When everything was in Hadoop at Twitter, we spent all of our time trying to manage the jobs. The fare scheduler, the ingestion was coming in. Does it take priority over revenue jobs that we're running? Right? So when you combine concerns, you're going to have problems, right? So separating concerns, I think, is an extremely valuable thing to do. Not to say that you can't do consumption and do work here and such and look at older, colder data, like you wouldn't necessarily want to do here, which is more, say a year and a half of data, but tags forever. But you have the ability to turn the dials and the knobs a lot better based on your usage. Does that make sense, sort of? I mean, I'll drill into it. Okay, so what I'm going to do is I'm literally going to walk through a piece of data comes into this architecture and how it flows all the way through. Okay? Because I could wave my hands and say, you're like, okay, well, where does it show up and how does it show up here, and then what do you do? I'm going to tell you exactly what we do, and then at the end of this, you guys can pick it apart. You can say, well, does that work, or why wouldn't that work, or how does that work? And I'm going to do my best to defend it. Okay, so we have, in our case, JSON messages coming in from all the apps, users, sessions, a bunch of other stuff, game event data, but whatever, let's keep it simple, right? So it's coming into your Kafka cluster, they're writing, they're appending to each topic, right, and each partition. Okay, what we do is we start up a Spark driver app, a Spark driver per application, which is a nice thing to do because then we can shut down WSOP if there's, all their data's bad, why process it, or whatever. We can, give precedence to their jobs as far as resourcing the cluster. This is our model. Oh, sorry, a little build slide problem here. So the second thing that we do is this is the global source of truth for the data in Playtika. So this is where all the users come together and where they have like a unique identifier assigned to each one across all applications. Okay. Clearly, there's going to be a mapping, right? Because remember, they have their own user IDs, their own, session IDs, and they're like a crazy GUID. But like, do you want to join on, what was that thing, a varchar 255 or something? Do you want to like have that in all your session tables, and then have the other one that's a UUID and then a GUID ID? I mean, that's just crazy. I mean, to think about writing queries that join those. So I'll explain what we did in that case. The point that I kind of want to bring about here is that I guarantee you have mapping tables. I guarantee you that you have domain tables to look up. I guarantee you that you're going to want to reconcile heterogeneous data. Bar none, unless you're not really processing data. So source of truth is here, but what we do on startup is we load that into Spark. Okay? So we load all the existing users and the mapping between the natural key and the Seria key, in our case an integer, to have that mapping across all applications. Because we can do that distributed in memory, and we get parallelization when we do the processing and joining to that memory with Spark SQL or whatever you want to use for that processing. So long-term permanent store is here, but when we do the processing, we can load it here temporarily. Again, separation of sort of concerns and be able to have the best of both worlds, okay? Sessions, we do map sessions, we do, I don't work there anymore. I was started, I mentioned that. We did map sessions as well, but you don't need to keep those forever because clearly, like, you're just keeping a session, so some web logged event as well, right? You're only going to keep a certain amount to find out if it maps to the user, right? Like the sessions are going to over the next 48 hours or even a few days, if the data is trickling in slowly, right, the user that's associated with that session, you're only going to need to keep like a certain amount of sessions. But you do want to know for this user, for this session, what game events they had or whatever, right? Very typical kind of, web log stuff. Okay, so now comes the really cool stuff and why I built this slide so you can look at it later and go, oh, that was genius, or I still don't get it, I don't know. But, so what we did, I'm going to talk to this a little bit more, is we use MySQL, and imagine that you have a table called a Kafka table, okay? And in our case, for every application, we had an app ID. And then what we did was we stored the offset range. So think topic, partition, and the offsets that you're processing at the time you're reading the data, okay? And then what we do is, while we're processing that chunk of data, you could do it in a streaming world, but I tend to, which I'll get to, tend to think in terms of more near real-time processing of data as quick as you can off the Kafka cluster. And then eventually, if you're going to write that data somewhere and you have to reprocess it, how do you reprocess it if you haven't designed like some batch of work? So what we did was we said, for this topic, for this partition, for the offsets that we processed, we assigned a batch ID, just an integer, and that gets stamped to the record that gets written into the data warehouse. Now if you have to reprocess it, which I'll talk about, you just delete everything related to that batch ID that you assigned, and you just start the process back from reading from, you just reset that the table to say, reprocess from where I should be, and it just goes going to go back in time. I'll explain that a little bit better. And then we have like the maximum, we call it a GID, a global identifier, maximum session and maximum user, because as new users coming in, you're going to assign a new ID, right? You're just going to auto increment. But that gets interesting when you have like multiple sources of truth. Like you start to think of like Snowflake, and how do I manage multiple contention of like assigning user IDs when multiple apps are running, and I'll explain that. Okay, so is that kind of making sense so far? Going too fast? Not too fast? Slow? Okay, come back. No, it's not making sense. Okay. She's like, I don't know. So the fourth step in the process is that Spark is reading from Kafka. As you might have guessed, in our case, it's sort of non-streaming because it's starting from the last set of topics and partitions and offsets that it read before and reading forward. Now, it can read all the way to end of file on Kafka, so it's going to get real-time data, but eventually you're going to have to do some processing with it. Sorry, you want to use the data. And then when you go back to Kafka, it's no longer real-time, right? I mean, you can try to do as fast as you want, so that's why I kind of put in, the optional parameters here, non-streaming. I think that's what usually people are going to start to come around to. Unless you're doing like a dashboard or something, you want to see it fairly near real-time kind of thing. But if you're going to do some transformations or reshape it and write it into another store, there's latency. There just is. Okay. So in our case, we're reading messages. The key is that we're reading messages. See why there's multiple arrows coming in from Kafka? We're reading messages using Spark in parallel. So your level of parallelism on reading messages in Spark are the RDDs, is the topic partition. So the level of parallelism reading Kafka are your Kafka partitions. Okay? More partitions, more parallelism for reading, right? But you gotta be careful you don't want too many of those things, because they're actually like files on disk and stuff, and you might have file on. So what we did was, we read into an RDD, the game events, users, sessions, etc. across n partitions. Remember this picture I had before where we have it's partitioned across all, across the cluster. Keeping in mind that as you're reading it, it's going to be the level of parallelism that you're reading, and then the RDD partitions that you're creating are going to be like a one-to-one with however you define in Kafka. Okay? Why is that important? So in our case, what we had to do, and I suspect everybody has to do something like this at some point, is that the data that's coming in, we might have seen this user before, right? We might have seen this session before, we might have written it to the data warehouse, that's why we created the mapping. So basically, we've assigned a unique identifier to the sessions and to the users in some cases in the incoming data, right? In some cases, not. So where we've already assigned them, we can create a different RDD with the users that have IDs assigned already, right? And maybe take the opportunity to reshape the data at that point, as long as we're going to read it and put it into a different RDD. You know, do a little parsing, you know, changing an epic to a nice timestamp or something, because we're going to do some execution with it, create another RDD. Same thing with sessions. And then now, what we can do is we can say, sorry, I jumped ahead. But now what we can do is say, all those that don't have a unique identifier assigned across all the different applications, we need to assign one, okay? And this is kind of cool. So, one thing that you can do is when you create the RDDs in Spark and the partitions, and in our case, they'll be all the ones that we need to assign IDs to. So we can say, how many partitions are there? You know, map partition with index, right? And you can get the size. So this partition has 100 records in it. This partition 2 has 1,000 records in it. Partition 3 has, you know, so many records. I know the number of records that I need to assign an ID to by just getting the size of the partitions. Okay? And you see the brilliance here. So then what we do is we say, I have 10,000 IDs that I need to assign to this set of data that I have to have a common, you know, surrogate key for the natural key coming in, right? So what do? So now I just go to this table that's in MySQL and I say, select for update, which is going to hold a lock, just a brief lock on that table, to say what's the last integer value on that table, the last user that I assigned, plus 10,000 that I need to assign. Boom, quick write, no big contention, no hard snowflake problem for like adding these. Now all I have to do is go through each RDD and actually assign, you know, this ID to another RDD, you know, a unique identifier to every single row. So now I have an RDD of all the users in the sessions that already have IDs assigned globally, and I have another set of RDDs and partitions that are assigned. Now all I have to do is do a SQL union between the two, and I have my full set of data that I need to insert with global unique identifiers for all of them. And every app that comes in can come in independently of this, and hardly any contention at all, and this actually scales extremely well, by the way. You can read about the select for update. Okay, so I have in memory now my full set of RDDs with all my surrogate keys, some transforming that I want to do. Now I need to load it, right? Because you got to load the data. And all this has been done in partition, in memory. So one of the things that really bother me, I guess, is we could load tremendous amounts of data in Vertica, but not nearly as much as we wanted to with the volume of data that we had at Twitter. And it just kind of always bothered me. You can load data pretty fast in Vertica or other stores and Redshift and stuff. But what kind of bothered me was, remember that slide where the data that was coming in and said, I need to hash this, and it goes to this node, this node, this node? I'm like, well, that's crazy. I already have the actual row. I have the ID that I want to hash on. I have it in memory. Why do I have to shuffle it around? So I convinced Vertica to give us their hashing algorithm. And then we do the hashing algorithm in parallel in in-memory RDDs. So now I know exactly which node it goes to. So guess what? I partition matching the exact nodes in my cluster in Vertica, bucketing, just a group by, right, by this hash that gives me an even distribution. But the real benefit is that if you're used to using something like, I mean, everything has, if you're a SQL server, BCP, right? If you use Vertica, it's a copy command. I mean, everybody has a bulk copy insert command, right? Typically, you know, maybe pipe it to standard in, or it reads it from file in some delimited format and bulk copies it into your data warehouse, right? Vertica is no different. What we did was we wrote our own user-defined library source, and what it is actually is a TCP server, little stub, runs on all the nodes in Vertica, and it sits there and listens on a port. It's just like a UDF. Sits there and listens on the port, and then you can stream data, and guess what? We already have the buckets. Everything in this partition I know is going to node 1, It's just sitting there listening on a port. We literally open a port, stream the data directly from memory, and it writes it directly to that Vertica node with no data movement, all in parallel. Parallel ingestion from Kafka, parallelization and performing transformations, and then reshaping the data with parallel loading. I have an animation. There we go. So we just pour each over the partitions, and we just open a socket and just stream the data directly in the node, and Vertica goes, oh yeah, you belong here. No need to move it, okay? So parallelization through the streaming transformation loader. Okay, now we're not quite done yet though, by the way. So now what do we want to do? We have data in our data warehouse. It's nice and structured. It's been reshaped. It's like relational. It has keys assigned. It's been loaded in parallel. It's a beautiful thing. But we still have this memory still and this data in memory. Let's not lose that, because we might want to just keep this nice structured data around for maybe a year and a half, but we'll build aggregate tables that analysts are using and keep those forever, right? But we don't want like the raw data there forever, in part because there's nobody from Vertica here. Is there? They charge you for storage and licensing, so you want to kind of manage that. Maybe change your retention policy there. Cheaper commodity hardware up here. I'm just sort of saying. So what you can do though is you can then write that raw JSON data into HDFS, right, or S3 or wherever you want to write that. You've already reshaped your data to target the tables that you're going to write to in your data warehouse, right, in your long-term store, because you had to match like this is the customer and it has these fields and whatever, right? And you're going to write that. So you already have in memory your RDD that looks and smells exactly like the tables in your data warehouse, right? It's been you've reshaped it, you've transformed it, you've cleansed it, you've done stuff with it. So save it. Save it in HDFS. Save it in a work file, Parquet file format, snappy compressed. Now the benefit there is you can write SQL off your structured query and stuff like that, your consumption, and manage, scale, etc. here. But if you change the retention policy here and you want to read the data that's really old, because you might later on go, we need to look at that old data. Now I can use Spark SQL or Hive or Impala to read that data that looks exactly like a nice structured format that's not just a messy data lake of unstructured data. Because I already had it. Just flush it to disk. So now I have the unstructured data that I could do stuff with as well. I have the structured data, and if I want to do some stuff and read this data here and match it to Kafka, I can do that. And, get this, Vertica has a way now to do vSQL, which is basically I can read data in SQL here, and I can have external tables here in org file format, think Parquet file format, columnar store, right? And do heterogeneous joins between the two. Oh my God. I mean, it used to be you had Impala or you had, Pig or you had Hive, you were stuck here. Like you couldn't marry the two data sets between the two. Now you can. By the way, it's really fast. Faster than Impala, I'm just saying. So you can have the external tables here as well. Vertica also has, just came out, just give them a quick little plug. They have a Kafka connector, so you can read topics off of Kafka in a scheduled manner and write them directly to Vertica. I think that's pretty powerful, but I think clearly you're always going to reshape the data and reformat the data, so you're going to have to do something with it, right? And then maybe that goes back to the model I mentioned, like maybe you're going to read Kafka, reshape it, throw it back on its topic, and then it just writes it into Vertica. It does it in parallel by topics directly into Vertica. It's all about parallelism. When we created this method and wrote this, we were working closely with the Vertica devs, and then as they were doing the Kafka connector, we shared notes. Vertica also has a Spark connector now, which I can talk about if you want to talk about it offline if you use Vertica. Good and bad in the beta program. The good news is you can read out in parallel directly to Spark RDD, and it'll read it directly from the nodes. They use the same kind of technique that we did, just read the data from the nodes, load it into parallel into your Spark RDDs, and then do some processing. The processing from Spark RDDs into Vertica doesn't perform all that well. Sorry. Okay, so I just want to kind of show you, kind of give it away. So we did some benchmarking, some testing of this methodology of loading into Vertica. just on an 8-node cluster, 451 gigabyte data set. We were able to load it into Vertica. That means reading it off of a set of 8 nodes and copying it across the network, and then writing it into Vertica in 7.5 minutes. 2.42 billion rows. So usually this is when people applaud. I'm just saying, you don't have to applaud. I'm just saying. So Facebook actually showed last year, kind of stole the show at the Big Data Conference. They loaded 35 terabytes an hour. I mean, come on, that's huge, right? They loaded 35 terabytes an hour of data, working with working with Vertica. But it took them 270 nodes to load that much data into Vertica. Okay, and 45 of them, or 250 of those nodes were storing data, but the rest of the nodes, you do the math, 270 minus 15 is what? 55, sort of, around there. 55 nodes were dedicated to just doing the shuffling, okay? In our model, parallel loading, they're all storing and then there's no shuffling, okay? So we could do it in 81 nodes versus 270 nodes. That's real money at the end of the day, and that's pretty fast. So key takeaways are parallelism with Kafka reads to spark RDDs in memory and writes to Vertica in parallel through TCP server. It just rocks. We can load 36 terabytes an hour with only 81 nodes, and we can do that even faster. We don't even have to have ephemeral nodes assigned to just sitting there idly. It gives us parallelism off the Kafka reads directly into RDD partitions. We do the a priori hashing, like I mentioned, and the single copy command doesn't consume memory across all nodes, where other methods require memory across all nodes. So very low memory footprint, all 32 CPUs, just keep you busy. Thank you. Happy to field questions, and I'll stick around for a while as well if you want to ask me something really hard. Yeah.
Just out of curiosity, you were talking about session data a little bit earlier, and I wondered if you had tried or thought about trying exposing session identifiers and session data as Spark broadcast variables. Does that make sense for the handle distribution of session across your Spark cluster?
Yeah, so the question was, where you have, correct me if I'm wrong, where you have commonality, like we're assigning a unique identifier that needs to be available across distributed data sets and RDDs, did you ever think about broadcast variables? And the answer to that is yes. Anybody else? No. And so yes, we did. Broadcast variables, we do use them for certain things, like sort of caching connections and a few other things. It's not really a good model because it goes back up to the driver. So anything going back to the driver, we were talking about this earlier, you want to have your executors, the things that are running on all your nodes, the processing near the data itself. You want all of your processing there, and coming back to the driver, aside from like a final result set or something, sort of a final shuffle or a group by kind of thing, you don't want to do a lot of state. Like you want to think stateless, 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 and broadcast variables are kind of nice for some commonality. We used it, and I think maybe this is where you're going. We used it sometimes for the some auto incrementing type stuff, where they could go back and then the drivers could say, oh, what is the current, the last auto incremented ID, so I don't have to read it from the database or something. So you can do it for things like that.
I was thinking mostly specifically about session data because, it seemed like it might be a good mechanism for having user data spread through the cluster for real-time machine learning kinds of purposes. So I think that was what I was thinking.
Right.
I don't know if that's a good idea.
We had a lot of sessions, so we didn't, like lots.
Yeah.
So
that would be it.
yeah, so I wouldn't try to serialize on something like that, but yeah, it's a good question though, really good question. Yeah.
Anything to say about size of RDDs, any experience in that area?
Yeah, so the question was size of RDDs. There's some good and bad things to consider there. How big are your objects? How much are you trying to keep in memory? That factors into it. The general processing rule, like I said, is 2-ish RDDs per CPU is good for processing. But there, when you have a lot of data and memory spread across your cluster, it's something to consider. Now, one thing that in our case, and this does come to the size of RDDs, is we want to bucket. Typically, you want to bucket your data at some point in time for like consuming, or in our case, affinity to the Vertica nodes. So we did have to reduce the number of RDDs down. So there is a reshuffling now from in-memory to another set of memory. So, I mean, there's no perfect formula. It kind of depends on your use cases and stuff. There's some stuff that you can do to kind of do a little bit of math around that. It's not a great answer for you, but yeah. Oh, sorry.
I think Jack will stick around so if you want to keep asking questions. Just quickly, I want to thank George and Team One for hosting tonight's event. So a round of applause for them, please. Also, quickly want to mention, if you parked outside, it's only free parking until 9 p.m. So if you don't get a ticket, move your car before then. Thank you, Jackie, for presenting today. You can send over your slides. And,
I'll put them up on SlideShare, and if your company needs some help and some solutions, call me maybe. But this whole staff is what we kind of specialize in, so I'll send them out and there's contact.
Okay. Alright guys, thank you very much for coming and I'll see you those days at the holiday party. Thanks so much.
I'll stick around and be happy to talk to everybody about it later on if you want to keep drilling down. So I'll probably just take questions at the end, if you can, because there's a lot of material here to cover. So try to remember what you wanted to ask me. We're going backwards. There we go. Okay, quick agenda. I'll give you a little background. Some I've already given you, some on myself, some on kind of how I came to evolve my thinking around data pipelines and how I got there, including Lambda influences and stuff, which we'll talk about. Then I'm going to give an overview of PSTL, so think streaming, transformations, and then loading, but all in parallel. So parallel streaming, transformations, loader, think Kafka, Spark, and then whatever your target store is, whether it's Vertica or something else. I'm a pretty big Vertica fan, so happy to talk to you about that, versus like say Redshift or something. And then I'm going to talk about the parallels in Kafka Spark. I already kind of gave this away. And then I'm going to drill down on actually some of the details. I wanted to really give kind of prescriptive guidance around the whole data pipeline, the big data infrastructure, rather than just kind of waving a bunch of hands and saying there's streaming, et cetera, and such. So I'll literally walk through every bit of functionality that we implemented in my prior capacity, where I was VP of Big Data at Playtika. And then some Vertica performance numbers that are pretty impressive using this architecture, so we'll talk about that. So starting with the background, kind of my background, kind of how we ended up here. I've been doing this for about 29 years, so I'm old, is what I'm saying, really. But what I've seen, starting with right out of college, started with the 4GL, relational database management system, so clearly I have a bias around relational data, but it kind of colored my thinking pretty early on. So I was an MIS director of several startup companies back in the day, so I've been a startup thing for a while. Then I was a self-employed consultant, where we did things like intercepting all the database calls in this fourth generation language to retrieve data from btrieve, and then honestly this seems kind of crazy, but what we did was we used this 4GL language to actually write data into DB2, so that you could actually write code really fast in 4GL, but store your data on the big iron. So I've been kind of in the database realm for quite a while, all the way back to the Box Pro Sybase before it was Microsoft and SQL Server, etc. And then just general design patterns have always kind of fascinated me as well, which we'll talk about a bit more. I was a lot of things at Microsoft. I was there for like 15 years, where I invented this system called Shuttle. Think about an ETL system that you don't have to write code for, but it's completely extensible. All of MSN.com data, including Bing Mobile, I think is using it now. So all kinds of data flowing through that system. I think it's actually one of the longest lived products to Windows and Office product, actually. So it's been around quite a while. But this started my thinking around distributed processing, in particular in a traditional ETL pipeline, and the power of scaling. We built it off the back of Microsoft MSMQ, kind of like RabbitMQ if you've used that. Kafka, I think, is a much better queue model, if you will. Anyway, some of the people that influenced me there is, back in the days of star schemas, Ralph Kimball, etc. And particularly this person, Steve Butler, who was an architect there, kind of influenced my decisions in architecture. Then I was at Twitter for a while, kind of pre-IPO, through the IPO, and post-IPO, where I was manager of the analytics data warehouse team. Basically, think of, is this getting louder, or is it just me when I hold it closer? Or is it too loud when I, yes? Okay, not too good, okay. Because I can just project. In the early days, I was in the core storage team, Hadoop, HBase, Cassandra, and then Blob Store, which is our binary large object store for images and photos. But mostly what I was really involved in was Vertica, which is an MPP columnar store, scales like nobody's business, where we were moving a lot of stuff out of Hadoop, and instead of running pig jobs, pig was pretty big rather than SQL. That's just me. Be happy to talk about that. But no ETL, I think there's a little bit to truth to that, and I think it's really about the extract versus the transformations and reshaping the data into some kind of structured data and then some loading, but we'll get into all that. So in some regards, I do agree with the no ETL and the traditional kind of extract model, which we'll talk about. But mostly what I want to talk about, because everybody has some new flavor of everything from ETL to ELT to no ETL to Lambda, and I've been kind of prescribing this new thing that I talked about at the Boston or the Big Data Developer Conference in Boston. Are there any Vertica people here that are familiar with Vertica? MPP columnar store? Okay, fair enough. Then everybody else is going to be bored. No, I won't go over a whole lot of things there, but so some of this comes from that talk that I did there. But really what I want to talk about is parallelism through the entire data ingestion pipeline, which we'll talk about. So from streaming to doing your transformations, reshaping the data, and then loading your data, whatever your eventual target store is, whether it's HDFS or if it's a relational database model or something in Vertica. Substitute whatever you like, Redshift, what you guys are using. Okay. Everybody else just writing into HDFS and Hadoop or something? Sorry. Apparently it works fine. Just so I can get a sense for everybody else, Spark. People in the audience that are using Spark. I know you're having problems. Spark, yeah. More in development or in production, a little bit of both? Yeah, okay, cool. Okay, so that's good. How about Kafka? Anybody using Kafka or, okay, cool, or evaluating Kafka or using Flume or Scribe? Sorry if you are, maybe something, okay. Okay, so let's go ahead and jump in a little bit here. So, like I said, just fair warning, I violated all the best practices in PowerPoint. So to do like 3 bullet items, I worked at Microsoft for 15 years and I did a lot of talks. So I've been trained not to do everything that I just did here. But I haven't worked at Microsoft for a while, so I'm going to do whatever I want. So there's going to be a lot of information, it's pretty packed. So a lot of committers were on our team. But basically all the data in and out of Vertica from Hadoop and HBase, etc. Was kind of my team's responsibility. And then kind of coloring my thinking were the Professor Stonebreaker and such kind of colored my thinking at that time. Moved from Silicon Valley down here a little bit ago, a year and a half, 2 years ago or so, where I was Playtika's VP of Big Data, which I'm going to give kind of a canonical example here pretty soon. People that influenced me through this process were Jay Krebs. Did anybody see Jay Krebs when he was here recently? Yeah, from Confluent. Love that guy. Mostly because when you build things, it needs to be operationally robust if you have to support it. That's one thing if you don't. And kind of the founder of Kafka. And then Mike Lambros, Spark SQL, love Spark SQL. We'll talk about it some more. And then Chris Bowden was one of our architects on our team, based basically I was on a quest for many years to build a unified data pipeline with parallelism throughout. From the streaming of data, through the transformations, reshaping of the data, from semi-structured to structured data, into relational data and all points in between. So I've been thinking about this for a while, doing a lot of research, with a lot of companies, a lot of experience, and what you're going to see is kind of the fruits of that labor, and you can borrow some, all, or I can help you build some or all of it as well. But the main thing was, it had to have the attributes of operational robustness, because it has to have high availability. You know, for example, when I was at Twitter, even though I was a manager, I was on call 2 out of every 4 weeks. And that's a pretty big task to be on call supporting all analytics team. And so, you know, you want to build things that don't wake you up during the night and keep you up at night, which you did an okay job of, sort of.
How many of you attended? Okay, I expect everyone to show up over there, so one will be taking attendance. Just kidding. So if you haven't signed up, please do show up. It's a holiday party, it's a networking event. So it's community driven. We are doing this in coordination with several meetup groups, so it's not just the big data. So you have MySQL, PHP, Couchbase, you name it, we have it out there. So it's a good way to meet the community folks out there. We also have several companies coming down, if you want to talk to us what different companies are doing with the kind of technologies they're using, kind of tools they're using, you should please attend, network and talk to them. Other than that, with that, tonight we have Jack, he's going to be presenting, and I'm going to let Jack do the talking. So without further ado, Jack.
Thank you, Subhash, and thank you for our host. Really appreciate the space and Subhash setting this up. Subhash mentioned, I'm Jack Dudenkoff. I'm currently started a startup because everybody has to do a startup now and then. And basically, the company is big data infrastructure, big data infra. Feel free to ping me if you're looking for help on any kind of stuff that we're going to talk about. Basically, the whole data pipeline and big data infrastructure supporting analytics. I'll give a little bit of background on myself going through the slides, so I won't go through a whole lot of stuff. But basically, the slides are going to be extremely dense, full of information, because I wanted to give you, and I'll post this up on SlideShare, but I wanted to give you the slide deck so that you can kind of look at it later on and kind of get a little bit more information rather than just me hitting a bunch of bullet items and then you leave here, nothing to take with you. I titled this No ETL.